Welcome back to Math Success Seminar. We're going to go over a few more examples of adding and subtracting fractions. So before getting too into it, because I do have a couple examples in mind, I want to talk about, in more detail, mixed fractions and improper fractions. So this is called a mixed fraction because we have a whole number here. So this is your integer portion, I guess. And then you have a fractional portion. So it's like whole number and then the fraction 3½ This is an improper fraction because the numerator is bigger than the denominator, meaning it's bigger than 1. Because in this case, 1 would be 7/7. So anything that's 7 or above, I guess, would be considered improper, or above 7. So how to switch between the two? Well, this is a pretty simple one. But what you want to do is you want to start with your denominator. Your denominator is going to stay the same. And now what you want to do is you want to do your denominator times your whole number portion. 2 times 3 is 6. And then you want to add this numerator. So this will be 6 plus 1, or this is 7/2. Now how to change back 10/3. We could use long division. I'm going to show that next. But you want to think, how many times can 3 go into 10? So this is where knowing your multiplication tables really helps you out and speeds things up. Because how many times can 3 go into 10? Well, I know it can go into it 3 times. 3 times 3 is 9. So I'm going to take 9 away from this. And you always want to keep your denominator the same. So this is 10 minus 9, which is 1/3. So 3⅓ is the same as saying 10/3. This goes back to so if I have pieces like this and I'm splitting each bar into 3 different pieces. I know I have 10/3, meaning shaded, shaded, shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/3. But how many is that? Well, it's 1 bar, 2 bar, 3 bars, and then 1/3 of a bar. So visual representation of how to do that. And weird ones, maybe let's do like 7, 14 and 4 7s. It's not the most pleasant mixed fraction, but you can take that off to the side. What's important is knowing the method. So you're always going to start with the denominator. We know our denominator is going to be the same. We're going to multiply that by 14 and then add 4 to it. So first we need to know what 14 times 7 is, and you can work that out on the side. 7 times 4, 8. Let's see, this is 2. 7 times 1 plus 2, 98. And now we know we're going to add 4 to it. So this will be 102. 102/7. Why is this useful? Well, whenever you're multiplying or dividing, I think it's most useful, but using it for addition subtraction is also useful. There are other ways to do addition subtraction that don't require you to change mixed fractions into improper, but I'm going to show you how to do the way where you have to change, or you could change to improper fractions, add everything together, change back to a mixed number. So I'm going to choose ones that aren't super crazy looking. 2 1/3 plus 4 3/4 plus 7 and a half. Okay. Seven and 2/6. Let's make this one minus. Let's be tricky. So the first thing I recommend is changing all of these to improper. So 2 times 2 is 4, plus 1 is 5. 4 times 4 is 16, plus 3 is 19. Right? Yeah. 6 times 7 is 42, plus 2 is 44. So now we can add and subtract them, right? Not quite yet, because all of the denominators are different. So we need all of the denominators to be the same. How do we do that? Well, we have to find the least common multiple between 3 numbers now. Before I was just doing 2 numbers, but now we have 3. So we could write out the multiples of 2, 4, and 6. I'm actually going to show this both ways. 2, 4, 6 times 1 times 2 times 3 times 4 times 5 times 6. And if you like this method for this part, you can kind of stop the video, or 3, 2 times 4, 2 times 5, 2 times 6, 4 times 1, 2, 3, 4, 5, 6, 6, 12, 18, let's see, 24. So notice this one, even though these are all relatively small numbers, we don't have a number that matches all 3 columns. 2 is pretty versatile though. Actually, I'm sorry, we do. Never mind, I was looking at the wrong number. We do. 2 is always versatile because we know 2 is going to go into 4 and into 6. So 12, 12, 12. That means our LCM is 12. I'm going to write LCM, or LCD in this case, because a D for denominator is 12. So if you like this method, you can stop it here. The other method, which this will be more useful when you have big numbers that you really can't tell if they share factors or not. I'm going to do a factor tree. So 2 is already prime. I'm going to do a factor tree to 4. 4 is 2 times 2, which is prime and prime. Do a factor tree to 6, which is 3 and 2, which is prime and prime. So I'm going to write out each of these in their prime forms. This is already prime. This is now in prime form. This is now in prime form. So what do these 3 numbers share? Well, they all at least have 1, 2. So for your LCM or LCD, this is 2, 2. They all share 2, so you list the 2 once. So that was the common factor. What are the uncommon factors? Times 2 and times 3. So this 2 and this 3 are only going to get written once. And now you can multiply it out. 2 times 2 is 4, times 3 is 12. Now, we have to resize all of these to become larger looking equivalent fractions. And then once all of them have the same denominator, then we can go about adding and subtracting them. So I already got LCD written up here. I'm going to leave myself quite a bit of space. This is how I always recommend doing this. Leaving yourself a little bit of room so you can fit everything, which I'm going to run out of room in a sec. I'll get to that. That's the beauty of videos recorded for later, is you can stop them at any point, fast forward or rewind. So how do we make this into a 12? Let me rewrite this in its prime factors. So what do we have here? We have a 2, meaning we don't need to, we can pretend that it's this 2 here. So what do we need to multiply by? 2 and 3, which is 6. So multiply by 6, multiply by 6. Whatever you do to the bottom, you have to do the top. That way it stays equivalent. 4 is 2 and 2. So what is 4 missing? How do we make that into a 12? We multiply by 3, multiply by 3. And now 6 is these two put together. Boom, those two. So how do I make that into a 12? Multiply by 2, multiply by 2. So now that we are sizing all of them to be our least common denominator, I'm going to make a little bit more room. Start up top. So 5 times 6 is 30. 2 times 6 is 12. 19 times 3, and remember it's okay to take them to the side, work them out, and then put them back into the problem. 3 times 9 is 27. That will be 57. So this becomes 57 over 12 minus 44 times 2 is 88 over 12. So now that I rewrote it, I'm just going to wipe all that off. Now that all the denominators are the same, what we're actually doing is combining the numerators. So 30 plus 57 minus 88. And you can do this 2 numbers at a time. You don't have to do all of them. I'm going to do this addition here first. So 30 plus 57, that's a 7, that's an 8. So now I'm going to rewrite it 87 minus 88. Now this, you could handle a few ways. If you're comfortable knowing how to organize these, you can stack them vertically already. So which one of these has the greater absolute value? 88 does. It's got a negative on it. And we're going to add 87 to it. So different signs, find the difference, keep the greater sign. So really we're just subtracting these. 88 minus 87 is 1, but notice I always put the number with the larger absolute value on top. That way you know what sign the number is going to become, -1. Another way to do this is with keep, change, change. And this is more of an organizational thing. If this doesn't work out for you, don't worry. If the one before made sense, you can go ahead and use that. But whenever you have a subtraction symbol, you're going to keep the first number, change the sign, change the sign. So keep, change, change. Change it to addition. And now we're adding the opposite of 88. And now you can organize it. If this helps you keep everything straight, go ahead and do it. The important thing is different signs, find the difference, keep the greater sign. So we know the difference is 1, keep the greater sign. So this number, completely simplified, is -1 over 12. And this is already in lowest terms because 1 is 1. We can't make that look any smaller than it is. Since this video has already been going on for quite a bit, I wanted to just list a very detailed process on how to change mixed into improper and how to combine things together. Since I made up this example off the top of my head, I was hoping that we would get back to a mixed number. So let's pretend all of this worked out to be 13 over 12, -13 over 12. So now, since we were given mixed fractions in the first place, we have to figure out how to get back to a mixed fraction. This negative, you want to just keep that negative out front. It has nothing to do with separating these into smaller pieces. This number is, it has the property of being negative, so you just leave the negative here. And now, how many times can 13 go into 12? 1 time. And if I take 12 out of 13, I'll have 1 left over. And that's just a quick way of how to change back to mixed if the answer were negative 13 over 12. Well, this was a more detailed version of adding and subtracting fractions, including mixed numbers. And hopefully this will serve as a good tutorial for future homework problems, or I mean, if you're studying for a quiz or something. But next time, I will see you later. Have a good one.